In this activity, we'll be studying exponents. Next, we'll look at what's called prime factorization. Prime factorization is when a number is written as the product of its prime numbers. For example, 12 written as the product of its prime numbers is 2 times 2 times 3. And 35 written as the product of its prime numbers are 5 times 7. And the prime factorization leads us to the fundamental property of whole numbers that states that for any whole number, there is only one prime factorization. So to find the prime factorization, you first have to find a set of factors that when multiplied together equal that number. You then check to see if the factors are prime. If they are not, then you find a set of factors that would multiply together equal the number that's not prime. And you would continue this process until all the numbers are prime. On the next slide, I'm going to show you an easy way in order to find the prime factorization of a number. An easy way to find the prime factorization of a number is to use what are called factor trees. And you may be familiar with these from earlier schooling. But the factor trees are helpful when finding the prime factorization. If I want to find the prime factorization of 48, I write 48 at the top. Then I find two factors that are multiplied together that give me 48. And I will use, on the left-hand side, I use 6 times 8. I ask myself, is 6 prime? The answer is no. I ask myself, is 8 prime? The answer is no. So then I have to find the two factors that multiply together give me 6, and two numbers that multiply together give me 8. Well, the numbers that multiply to give me 6 are 2 times 3, and the numbers that multiply together are 8 are 2 times 4. So let's look at those numbers. 2 times 2 and 3 are prime, but 4 is not. So I have to go another level, and I just bring down the 2 and the 3 and the first 2, and then I have to break 4 into its factors, which is 2 times 2. So now all the factors are prime. So the prime factorization of 48 is 2 times 3 times 2 times 2 times 2, or it could be written as 2 to the 4th times 3. In the diagram to the right, you'll notice that instead of using the factor 6 times 8, I use 2 times 24. That equals 48, and I continue the same process. And you'll notice that I get the same prime factorization at the end as I did when I used 6 times 8. So when you're doing finding the prime factorization, it does not matter which factors you start with. You will always get the same prime numbers. So the prime factorization of 48, written in exponential form, is 2 to the 4th times 3. And we will do more of these in class, and that ends section 1.6.